Okay, in this video we'll begin to go through the homework problems, and we'll do this more quickly. So in number 3, we want to graph the linear equation x is equal to 4. Remember, our strategy for doing that is to come up with a number of points whose x-coordinate is 4. So we have x, y is 0, y is negative 2, y is 3. Then let's graph these. X is 4, y is 0. It's right there. X is 4, y is negative 2. X is 4, y is 3. We're going to draw a line through the points, and that is our equation x is equal to 4. Good. We'll go on to the next one. Y is equal to 2. Remember, our strategy here is to plot a number of points, all of whose y-coordinate is 2. Again, the x-coordinate can be anything. So we'll start with x is 4, y is 2. X is 2, y is 2. X is 0, y is 2. And we have this graph. Okay, well, you can pause this. We'll go on to the next problems. Okay, in the next two problems, all we want to do is to find the x and y intercepts of the graph of the linear equation. We're not asked to graph them, we just want to find their x and y intercepts. So, if we want to find the y-intercept, we're going to let x equal 0. We want to find the x-intercept, we let y equal 0. Remember that they're always opposite. X equals 0 is the y-intercept. Y equals 0 is the x-intercept. And when x is 0, we'll have the equation 3y is 12. Because 2 times 0 is 0, and 3y plus 0 is 3y. So 3 times what is 12? 3 times 4 is 12, and we get the equation, the ordered pair x is 0, y is 4. Right, let's go on to the y-coordinate, to the x-intercept when the y-coordinate is 0. When y is 0, we have the equation 2x is equal to 12. And 2 times 6 is 12. So we have the ordered pair 6, 0. So this would be the y-intercept. This would be the x-intercept. Alright, we'll go on to the next example. 3x plus 6y is 24. X-intercept, and I keep doing the x one first, even though I say x-intercept. So I'm going to set x equal to 0. Remember, that's our y-intercept. And when x is 0, we get 6y is 24. Y is equal to 4. The ordered pair is 0, 4. We want the x-intercept. Y will be 0. That's our x-intercept. And when y is 0, we have the equation 3x is 24. 3 times 8 is 24. And so we have the ordered pair 8, 0. And this would be, again, our y-intercept. And this our x-intercept. Alright, we'll go on to the next two problems. Okay then, in number 13, we want to use the intercepts to graph the linear equation, label the points corresponding to the intercepts. So we start with our equation 5x plus 3y is equal to 30. And we set x equals 0 to get the y-intercept. When x is 0, we have the equation 3y is equal to 30. And 3 times 10 is equal to 30. So we have the point 0, 3 times 10 is equal to 0, is equal to 30. And we have the ordered pair 0, 10. Next, we let y equal 0, and that will be our x-intercept. Along the x-intercept, we have y is equal to 0. We're left with the equation 5x is equal to 30. 5 times what is 30? 5 times 6 is 30, and so we have the equation 6 comma 0, the ordered pair 6 comma 0. So let's plot these. X is 0, y is 10, x is 6, y is 0. We draw our line carefully through the points, and there we go. All right, so that's number 13. We'll go on to the next problem. Okay, in problem number 15, we have the equation negative 12x plus 3y is equal to 24. So first we'll let x equal 0. Remember, that's our y-intercept. X equals 0, we have the equation 3y is equal to 24, and we know that 3 times 8 is 24, so we would have the ordered pair x is 0, y is 8. We'll plot that there. Next, we'll let y equal 0, and that is our x-intercept. And when y is 0, we have the equation negative 12x is equal to 24. And negative 12 times what? Negative 12 times negative 2 is 24. Don't forget the negative, because 24 is positive. We need a negative times a negative, and so we have a negative 2 comma 0. Negative 2 comma 0. And so then we're just simply going to draw our line through those points, and you can do that with a ruler and you'll get it. So we should be labeling the points here. Again, this is 0 comma 8, and this one was negative 2 comma 0. Right? We'll go on to the next problems. Okay, in problem number 23, we're going to try to scrunch this graph right onto the screen here so that we can work with everything all together. Alright, so a football team has an away game and the bus breaks down. The coaches decide to drive players to the game in cars and vans. 4 players can ride in each car. So we'll have 4 players per car, and we'll have X number of cars. Then we'll have 8 players, or 6 players rather, can ride in each van. And we'll have Y vans, so that we have 4 times X players sitting in cars, 6 times Y players sitting in vans, and when we add them together we'll get a total of 48. So our equation is 4x plus 6y equals 48. Again, this is given to you, but you're going to need to construct this equation on your own. Alright, so we're going to graph the equation using intercepts. So our equation again is 4x plus 6y is equal to 48. When x is equal to 0, what does x equal 0? That's our y-intercept. And what does that mean in the context of this problem? That means that we will have all vans. Alright, so how many vans do we need if we're not using any cars? So when the x is 0, 4 times 0 is 0, we get 6y is 48. 6 times what is 48? 6 times 8 is 48, and so we get 0 comma 8. So in this case the graph is not labeled for us, but we can go ahead and label it. So we'll skip every other one. So 2, 4, 6, 8, 10, and we'll plot this point at x is 0, y is 8. Again, the y-axis is vans. The x-axis is cars. Alright, along the x-axis, y is equal to 0, and that would produce our x-intercept. When y is 0, we get 4x is equal to 48. And 4 times what is 48? 4 times 12 is 48. And so we get the point x is 0, x is 12, y is 0. So we're going to skip every other point. 2, 4, 6, 8, 10, 12, etc. So we want to point at 12, comma 0, and we're going to try our best to draw a straight line through those points. Not great, but let's see. Okay, so with a little adjustment, maybe that's a bit better. Alright, so again, now we want 4 possible solutions for this. So I would suggest that you make a little chart at this point and put in our cars, again, is our X variable. Vans is our Y variable. And we know that when there are 0 cars, there will be 8 vans. When there are 12 cars, there will be 0 vans. So we can try some nice factors of 8. Certainly we can try, let's see, how about 2? So if we go down by 2 for the vans, let's see what would happen if there were 6 vans. It appears that maybe X is 3, Y is 6 might be a valid solution. So let's see if that's true. So we would have 4, let's write this in a different color, 4 times 3 plus 6 times 6. Let's see what we get. That's 12 plus 36, and that makes 48. Excellent. So that definitely satisfies the equation, and so we have another point here. That is when X is equal to 3, Y will be equal to 6, and I think from this point we should be able to see the pattern. Going up by 3, the next one should be 6. The Y's are going down by 2, so that should be 4. Then 9 and 2, and you could try all of those there to see. If we look at our graph, the X's are 3, X is 6 looks good, X is 9 looks good, so actually all of them actually look good according to the graph there. So you can either start with numbers or use the graph together with numbers to come up with some good solutions, and then look for patterns in the table. You do have to check to make sure that your numbers work, and you have to keep trying until you get some numbers that do work. But then after that, you can certainly go ahead and use the patterns in the table. Alright, we'll stop this video at this point here.